Hello students, welcome to lesson 2. We are studying application of derivatives, that is chapter 6. There are many subsections here. Rate measure we have done. Then we have started increasing and decreasing functions. Here in lesson 1 I have given you the idea of increasing and decreasing function. Then the theorem related to increasing and decreasing function, how to decide using the theorem, etc. Now let us work out a few more illustrative examples, that is examples which will help us to understand how to solve the question which are related to increasing and decreasing aspect of a given function. Then we shall take the exercise and work out as many examples as possible in this lesson. The remaining problems we shall work out in the next lesson. So examples. This is example 5 in the worked out section. Find the interval in which f of x equal to sine 3x, x belonging to 0 to pi by 2. That means in the first quadrant, increasing and decreasing. Now we have f of x equal to sine 3x and the given interval is x belonging to 0 to pi by 2. So now first we shall find f dash x, that is differentiate sine 3x, you get 3 cos 3x. Now what is the condition now? First one, now x belonging to 0 to pi by 2, 3x belongs to 0 to 3 pi by 2. So whenever x belongs to 0 to pi by 2, now the 3x belongs to 0 to 3 pi by 2. Therefore 3x belongs to 0 to pi by 2, sine 3x is positive, because in the first quadrant whenever 3x belongs to first quadrant, then cos 3x is positive. So this implies f dash x is positive. So that is whenever x belongs to 0 to pi by 6, because 3x belongs to 0 to pi by 2 implies what? X belongs to 0 to pi by 6. So here therefore we can say cos 3x will be strictly positive in the interval 0 to pi by 6, because 3x belongs to 0 to pi by 2. So x belongs to 0 to pi by 6. So cos 3x is positive. That means f dash x is positive in the given interval 0 to pi by 6, because the given interval 0 to pi by 2 we have to divide into subintervals. Then we have to decide where it is increasing and where it is decreasing. Therefore we can say in the given interval 0 to pi by 6, f dash x is strictly positive, therefore it is increasing. So that means in the first interval 0 to pi by 6, f is increasing. Similarly, second question is 3x belongs to pi by 2 to 3 pi by 2. That means in the second quadrant, pi by 2, 90 to 270. So in the second quadrant, so cos 3x is negative. Cos 3x is negative. Therefore, this implies f dash x is negative. And now, whenever 3x belongs to pi by 2 to 3 pi by 2, where x belongs to pi by 6 to pi by 2. And in this interval, cos 3x is strictly negative. So this implies f dash x is strictly negative. Therefore, in the interval pi by 6 to pi by 2, f dash x is negative. This implies in interval pi by 6 to pi by 2, f of x is decreasing. Therefore, the given interval 0 to pi by 2, we can divide into two intervals. One is pi by 0 to pi by 6, there it is increasing. Then pi by 6 to pi by 2, it is decreasing. So this is the answer. Let us proceed. Example 6. Prove that the function f of x equal to cos x is, first one, strictly increasing in the open interval 0 to pi. Then second, strictly increasing in the interval pi to 2 pi. First one is decreasing. Then neither increasing nor decreasing in the interval 0 to 2 pi. Actually third one is very simple, because suppose you show that 0 to pi it is decreasing and pi to 2 pi it is increasing. That means the function is both increasing and decreasing. Therefore, it is neither increasing nor decreasing in the interval 0 to 2 pi. So, the third one is very simple. Now, let us work out like this. We have f of x equal to cos x, and first interval given is 0 to pi. Now, first find f dash x. F dash x is minus sin x. Now, this is negative in the interval 0 to pi because sin x is positive in the first quadrant and second quadrant. Therefore, minus sin x is negative. That means f dash x is negative in the interval 0 to pi. This means it is strictly decreasing. Strictly decreasing. So, this is the first part. Same way in the second part, only interval is different. Pi to 2 pi, you see, f dash x is minus sin x, but minus sin x is positive in the interval pi to 2 pi because pi to 2 pi means it is in the third quadrant and the fourth quadrant. Third quadrant sin is negative, so minus sin is positive. Similarly, fourth quadrant is so minus sin x means sin is negative, minus sin x positive. Therefore, it is strictly increasing in the interval pi to 2 pi. Then the third one, as I told you, is very simple. In 0 to 2 pi, the function is both increasing and decreasing. Therefore, from a, f of x is decreasing in the interval 0 to pi, and from b, f of x is increasing in the interval pi to 2 pi. Therefore, f of x is neither increasing nor decreasing in the interval 0 to 2 pi. So, this is the answer. Next, example 7. Find the interval in which f of x equal to x square minus 4x plus 6 is A strictly increasing, B strictly decreasing. So, we have f of x equal to x square minus 4x plus 6. Therefore, what you have to do? Find f dash x, that is differentiation of x square minus 4x plus 6, that is 2x minus 4. Now, the first one is for strictly increasing function, what is the condition? F dash x must be positive. This implies 2x minus 4 is positive or x is more than 2. So, in the interval f is strictly increasing in the interval x more than 2 means it is 2 to infinity. 2 to infinity it is increasing. Now, for strictly decreasing function, what is the condition? It is f dash x should be negative. F dash x should be negative. Therefore, condition is 2x minus 4 less than 0 or x is less than 2. You can also write it in interval. Therefore, f is strictly increasing in the interval decreasing in the interval minus infinity to 2. So, 2 to infinity it is strictly increasing, and minus infinity to it is strictly decreasing. So, this is the answer. Next, example 8. Find the interval in which the function f given by f of x equal to 4x cube minus 6x square minus 72x plus 30 is, one is strictly increasing, second one is strictly decreasing. So, the method is same, only difference here is instead of quadratic polynomial, cubic polynomial is given. So, we have f of x equal to 4x cube minus 6x square minus 72x plus 30. So, what you have to do? First find f dash x. So, f dash x will be 12x square, that is differentiation of 4x cube is 12x square, differentiation of 6x square is 12x, differentiation of 72x is 72, differentiation of 30 is 0. So, you get 12x square minus 12x plus minus 72, but this we can write 12 can be taken out, x square minus x minus 6. This can be further factorized into x minus 3 into x plus 2. Now, actually there are two methods. One is called wavy curve method. In one of the examples, let me explain those things. Here we shall do by the normal procedure. For strictly increasing, we know f dash x must be positive. This implies 12 into x minus 3 into x plus 2 must be positive. Now, 12 into x minus 3 into x plus 2 positive implies x minus 3 should be positive and x plus 2 must be positive, because product of 3 number positive means 12 is already positive. Therefore, both x minus 3 and x plus 2 both must be positive. This is one case. Or this is a detailed method of solving. Second one is both should be negative. That is 12 is already positive. So x minus 3 must be negative and x plus 2 must be negative. And these two cases we have to take separately. Therefore, now consider first case, x minus 3 positive and x plus 2 positive implies x must be more than 3 and x must be more than minus 2. What is the common thing now? It should be more than 3. This implies x should be more than 3, because whenever x is more than 3, it is also more than minus 2, because the condition is AND. So this implies the required interval is 3 to infinity. That is, x more than 3 means what? It is from 3 to infinity. Therefore, in this interval it is increasing. One more case you have to take. Second case is, this is one. Second case is x minus 3 should be negative and x plus 2 should be negative. This implies x should be less than 3 and x should be less than minus 2. What is common? So this implies x should be less than minus 2. This can be written in the interval form like this. The required interval is therefore minus infinity to minus 2. So this is 2. Therefore, there are two intervals in which it is increasing. One is 3 to infinity, positive side. Second one is minus infinity to minus 2. Combining, we get the function is strictly increasing in the interval minus infinity to minus 2, then union 3 to infinity. So this is the way we can find the increasing interval by solving the given factors, either negative or positive depending on the condition. For increasing, of course, f dash x should be positive. Now one more thing we have to do, strictly decreasing, which interval? Let us proceed. Second one, for strictly decreasing, f dash x must be negative. That means what? 12 into x minus 3 into x plus 2 should be negative. This implies 12 into x minus 3 into x plus 2 should be negative, implies actually either x minus 3 should be negative and x plus 2 should be positive, because 12 is already positive. Product is negative means one should be negative, another should be positive. Or the second one is x minus 3 should be positive and x plus 2 should be negative. Here also same thing, we have to solve them. Consider the first case, x minus 3 negative, x plus 2 positive means x is less than 3 and x is more than minus 2. So now this is very clear. So the given interval is minus 2 less than x less than 3, or the required interval is minus 2 to 3, open interval. Now the second case is not possible, even common sense. Whenever x minus 3 is positive, x plus 2 cannot be negative, because x is a real number. Anyway, we shall find it. Consider the second case, x minus 3 positive and x plus 2 negative. This implies x should be more than 3 and x should be less than minus 2. So can you have a real number which should be more than 3 at the same time less than minus 2? Not possible. So this case is not possible. Therefore, only interval which we get is minus 2 to 3. Therefore, from 1, f is strictly decreasing in the interval minus 2 to 3. Now you can compare. See, from minus infinity to minus 2, it is increasing. Minus 2 to 3, it is decreasing. Then 3 to infinity, it is increasing. So this is the answer. Of course, there is another method, wavy curve method. Let me show you one such example later. So next, example 9. Find the interval in which f of x equal to sin x plus cos x, but given interval is 0 to 2 pi. 0 to 2 pi means all the four quadrants, first, second, third, fourth quadrant, is strictly increasing, strictly decreasing. So procedure is same. We have the function f of x equal to sin x plus cos x. What is the condition? F dash x first we have to find. So f dash x will be cos x minus sin x. Now f dash x equal to 0 implies cos x minus x equal to 0. So this implies sin x equal to cos x. So now which gives two values, x equal to pi by 4 and x equal to 3 pi by 4. So this is how we can find. So there are two values in the given interval 0 to 2 pi where sin x and cos x both are same. That is, one is pi by 4, another one is pi by 4. So now we can divide the interval. Therefore, here you see we have to do like this. The entire interval 0 to 2 pi can be divided into 3 intervals. What are the intervals? First one is 0 to pi by 4. Second one is pi by 4 to 5 pi by 4. Third one is pi by 4 to 2 pi, because 3 sub intervals we have to divide. Now what we have to do is f dash x is positive in the interval 0 to pi by 4. 0 to pi by 4 belongs to first quadrant, and there f dash x will be sin x minus cos x, and it is always positive because cos x is in more than sin x in the interval 0 to pi by 4. Similarly, pi by 4 5 pi by 4 minus and at 2 pi, there also cos x minus sin x is positive. Therefore, here it is strictly increasing. This implies f of x is strictly increasing. And second, f dash x is negative in the interval pi by 4 to pi by 4. So, there is one more thing. See, in the first interval increasing means in the second interval, subsequent interval, it cannot be increasing because it should be increasing and decreasing and then increasing. Therefore, here this is strictly decreasing. So, this is what we have to do here. Now let us go to the exercise 6.2. A few examples let me take today. First one, show that f of x equal to 3x plus 17 is strictly increasing function. So what is the condition for strictly increasing function? Now we have f of x equal to 3x plus 17, f dash x equal to 3, and it is always positive. That means by theorem this is strictly increasing function. F of x is strictly increasing function. You can also use the definition to show this one. Second example, show that f of x equal to e power 2x is strictly increasing function on R. That means for all values of R. In fact, you have seen exponential function ex. It is always increasing function. E power 2x is also increasing function. But let us prove using the differentiation concept. We have f of x equal to e power 2x. Find f dash x. F dash x will be differentiate e power 2x. It is 2 into e power 2x. And 2 into e power 2x is always positive, whatever may be the value of x. This implies f is strictly increasing function on R. So this is the second example. Third one, show that f of x equal to sin x is strictly increasing in 0 to pi by 2 and strictly decreasing in pi by 2 to pi. So neither increasing nor decreasing in 0 to pi. Definitely, because in the first one 0 to pi by 2 increasing, second pi by 2 to pi decreasing. So in the given interval 0 to pi, it is both increasing and decreasing. So it is neither increasing nor decreasing. Therefore C is very simple. Now f of x is sin x. Therefore f dash x equal to cos x, and in the interval 0 to pi by 2, x belong to 0 to pi by 2, f dash x cos x is always positive because in the first quadrant cos x is positive. So this implies f of x equal to sin x is an increasing function in 0 to pi by 2. Next, in the interval pi by 2 to pi, that is in the second quadrant, whenever x belongs to pi by 2 to pi, f dash x equal to cos x, but cos x is negative in the second quadrant. Therefore f of x equal to sin x is decreasing in the interval pi by 2 to pi. The third one is very evident. In 0 to pi, f of x is increasing in 0 to pi by 2 and f of x is decreasing in pi by 2 to pi. Therefore, it is neither increasing nor decreasing in the interval 0 to pi. So, first it is increasing, then it is decreasing. So, this is the answer. Question number 3. Then question number 4, find the interval in which f of x equal to 2x square minus 3x is strictly increasing, strictly decreasing. We have f of x equal to 2x square minus 3. Therefore, find f dash x, that is 4x minus 3. Differentiate 2x square, 4x. Differentiation of minus 3x is 3. Therefore, minus 3. Strictly increasing, what is the condition? For strictly increasing function, f dash x should be positive. This implies 4x minus 3 should be positive. This implies x should be more than 3 by 4. Of course, you can write it in the interval form, that is x belonging to 3 by 4 to infinity. That means the interval 3 by 4 to infinity, f is strictly increasing. Similarly, for strictly decreasing, what is the condition? For strictly decreasing function, f dash x must be negative. That is 4x minus 3 should be negative. Therefore, x should be less than 3 by 4. Therefore, in the interval minus infinity to 3 by 4, f is strictly decreasing function. This is the fourth question. Fifth one, find the interval in which 2x cube minus 3x square minus 36x plus 7 is strictly increasing and strictly decreasing. So we have done similar one question in illustrative example. F of x equal to 2x cube minus 3x square minus 36x plus 7. Therefore, f dash x first find. So 6x square differentiating 2x cube. Then minus 6x, that is differentiation of 3x square. Then minus 36 differentiation of 36x. 7 differentiation is 0. Therefore, f dash x is this one. Now, strictly increasing, what is the condition? F dash x must be positive. That means 6x square minus 6x minus 36 is positive. This implies 6 into x square minus x minus 6 is positive. This implies x square minus x minus 6 is positive because 6 cannot be negative. So factorize this, x plus 2, x minus 3. Now we can consider this way. This implies there are two cases. Product of two real number positive means both should be positive or both should be negative. That is x plus 2 positive, x minus 3 positive, x plus 2 negative, x minus 3 negative. Now take case 1. So x plus 2 positive and x minus 3 positive implies x should be more than minus 2 and x should be more than 3. What is common? So this implies f of x is increasing in the interval x more than 3. That is 3 to infinity. Then similarly, this is 1. Second one is, next consider x plus 2 negative and x minus 3 negative. This implies x is either less than minus 2 or x is less than 3. Combining this, we get f is increasing in the interval x minus less than minus 2, that is minus infinity to minus 2. This is the second case. So combine, one interval is 3 to infinity, another interval is minus infinity to minus 2. Therefore combining, we get f is increasing, strictly increasing in the interval minus infinity to minus 2 and then 3 to infinity. So this is the first part. Then we have to find whether it is decreasing. Strictly decreasing condition is what? F dash x is negative. That is 6x square minus 6x minus 36 negative. This implies 6 into x square minus x minus 6 is negative. This implies x square minus x minus 6 is negative. This implies x plus 2 into x minus 3 negative. Same thing, whatever we have done for the first part. Now we have to take two things. Whenever the product of two real number is negative, one should be positive, one should be negative. So you can take x plus 2 negative, x minus 3 positive, one case. Second one, x plus 2 positive and x minus 3 negative. Here also, definitely first case is not possible because whenever x plus 2 is negative, x minus 3 cannot be positive. And whenever x plus 2 is positive, x minus 3 negative, therefore you have to consider now two cases separately. X plus 2 negative, x minus 3 positive implies x should be less than minus 2 and x should be more than 3, which is not possible. So this is not possible. Second case definitely possible. X plus 2 positive and x minus 3 negative means x should be more than minus 2 but it should be less than 3. So what is the interval? It is between minus 2 to 3. Therefore the required interval is minus 2 to 3. So the function is decreasing in the interval minus 2 to 3. You can see very well here, minus infinity to minus 2 increasing, minus 2 to 3 decreasing, 3 to infinity increasing. So the entire real number is divided into 3 intervals. Next, sixth question. Find the interval in which f of x equal to x plus 1 cube, x minus 3 cube is strictly increasing and strictly decreasing. So procedure is same for all the questions. f of x equal to x plus 1 cube, x minus 3 cube. So first find f dash x. So using product rule you can find, first differentiate x plus 1 cube. So 3 into x plus 1 square, x minus 3 whole cube as it is. Second, differentiate the second one. So 3 into x plus 1 cube into x minus 3 square. Now you can take f dash x should be positive for increasing, that is 3 into x plus 1 square, x minus 3 square plus 3 into x plus 1 cube into x minus 3 square is positive. Now we can take 3 into x plus 1 square, x minus 3 square common, then it becomes 2x minus 2, positive simplification. So that is 6 into x plus 1 square, x minus 3 square, x minus 1 should be positive. So now here x minus 1 should be positive, or x should be more than 1. So because it should be positive means 6 into x plus 1 square is always positive, x minus 3 square is always positive. So positive is possible only when x minus 1 is positive. Therefore f dash x, now x equal to f dash x equal to 0 gives minus 1, 1 and 3. So these are the 3 points which are called critical points. Now you see how to decide where it is increasing, where it is decreasing. So here you can do one thing. This is called wavy curve method. Look at the given function f dash x, that is 6 into x plus 1 square, x minus 3 square, x minus 1. Here minus 1, 3 and 1, where the function f dash x becomes 0, those points are called critical points. So in the graph, in the number line, you just mark them, minus 1, 1 and 3. Now how to decide where it is positive, where it is negative? This is the procedure. Rightmost value is 3. More than 3 it is always positive. So that's one thing. Second, at 3 what happens is, 3 is a critical point, but its power is 2. Whenever the power is 2, the factor will not become negative. That means left side and right side of 3 is same. Already more than 3 it is positive means left side also it should be positive only, because it does not change the value. Now look at the second value, that is 1. X equal to 1 is a critical point once again, but its power is 1, x minus 1 to the power 1. So the value changes. So therefore left side of 1 you have to put minus sign. So first right side of 3 plus, then less than 3 also plus only, because power of x minus 3 is positive, that is even. Then another critical point is minus 1. There also minus will not change, because x minus 1 whole square, because x plus 1 whole square. So that is once again value will not change, sign will not change. Therefore this is the method of finding positive negative value using wavy curve method. Now from the graph it is very clear where it is increasing. 1 to infinity actually it is increasing, but 3 is a critical point. Therefore 3 we cannot include. Similarly, minus infinity to 1 it is decreasing, but minus 1 is a critical point. There it becomes 0. It is not strictly less than 0. Therefore we have to write like this: f is strictly increasing in the interval 1 to 3. 3 you have to exclude, 3 to infinity, and strictly decreasing in the interval minus 1 to 1, minus 1 to minus infinity to 1, minus infinity to 1. So thank you for watching this lesson. Please subscribe if you have not yet subscribed, and share with your friends. I have completed the 5 or 6 problems in this exercise. In the next exercise lesson, let us continue with the remaining problems, because this exercise is very big actually. Lot of questions are there. I think 16 to 17 questions. In this lesson, of course, this is comparatively lengthy, almost half an hour over. So let us conclude today. Please watch all the lessons, so that definitely will get the clear idea. Let us meet in the next lesson with some more questions. Till then, bye. Take care.